In this tutorial, you will learn how to solve all of the questions on homework 18. So the first section, the Monday box here, asks you to find the slope from the given points, and it provides you with the slope formula, which is delta y over delta x, or y2 minus y1 divided by x2 minus x1. And sometimes I find that it helps students if they put their two ordered pairs into what I call like a mini table here, and then it's a little bit easier just to make sure that you have the correct y values here. 5 and 9 are a pair, -1 and -6 are a pair, and don't forget your slope formula has a minus in the middle, right? So y2 minus y1. So this is my y2 value here, so 9, and my y1 value here, which is 5, that's my numerator, and -6 minus a -1, so you notice here I have two minuses in a row. That's going to give me a plus. So 9 minus 5 is 4, and -6 plus 1 is -5. So our rate of change, or slope, is 4 over -5. You can also write your negative sign to the side of the fraction. That is correct. And if someone had written their points in the reverse order of us, like if their mini table had this one listed as the first point, which is totally acceptable, and this one listed as the second point, then they would have resulted with a minus or negative sign in their numerator. And these three are all the same fractions. Doesn't matter where the negative sign is, denominator, numerator, off to the side, just as long as there is a negative sign somewhere, right? So let's take a look at question number 2. My y values are 7 and 3. So 3 minus 7 over 5 minus 5, and that results in a -4 over 0. Now, even though this value is correct, you can't stop here. If you have a 0 in your fraction, either in the numerator or the denominator, you must interpret it and go one step further. So a 0 in the numerator is totally different than a 0 in the denominator. A 0 in the denominator asks you to take something, -4, and turn it into nothing, which can't be done. It's impossible. Your calculator would give you an error if you said -4 divided by 0. So you need to understand that that slope of that line would be vertical, or what we call undefined. So that would be your final answer, undefined. So you cannot stop here. That's not far enough. You have to go one step further and interpret it as undefined. All right, let's take a look at question number 3. My two y values are going to be 7 and 7. So 7 minus 7 over 5 minus a -4, or 5 plus 4, and that gives me 0 over 9. Again, when you have a 0 in your fraction, you have to go one step further and interpret it. So if I have a rise of 0 and a run of 9, that means I'm a horizontal line, which just has a 0 slope. You can write it out in English, you could write it out in math, but the answer is actually 0. And then our final question here has a y values of 8 and 2, and x values of -5 and 1. So 2 minus 8 over 1 minus a -5 is going to give me -6 over 6, which results in the integer -1 when I reduce it. So try the 4 questions on your homework sheet, and go back and watch me as I solve these if you need some extra assistance. The second box asks you to write the equation of the line shown in the graph in slope-intercept form. Now remember, this is slope-intercept form here, y equals mx plus b, right here, y equals mx plus b. And the y and the x are permanent variables, but the m and the b are replaceable. They are replaceable with specific values. So this value and this value are replaceable. The m stands for the rate of change, or the slope, and the b stands for the y-intercept. So when we take a look at our graph, the y-intercept can be found by looking to see where the line intersects with the y-axis. That's how you find your value for b. Right? So if you're intersecting at +2, then your sentence after the letter x would have a +2 number. And now how you find the rate of change, or the coefficient of x here, is by counting the rise and run between 2 points on your line. So I have 1 shown here at the y-intercept, which is positive 2. And to find another point, you're looking to see where the graph has a perfect intersection with a corner box, like let's say here, or right here. Those are integer values, and they're the easiest to count. So it looks like I have a rise of 1 box and a run of 4 boxes. So 1 up and 4 right, so that is positive. So positive 1, positive 4. The equation of that line is y equals 1/4 x plus 2. And we'll do the same thing for number 6. This one has a y-intercept of 3. So I know after my x value I will have a positive 3. And then I see one other perfect integer point here. So I'm going to count the rise. And this time the rise happens to be negative 1, 2, 3, 4, 5, 6 units in the negative direction. And 1 unit is my run. So my rise is negative 6 and my run is positive 1. So this is a good answer. Y equals negative 6 over 1x plus 3. But we could reduce this, right? We could write this a little simpler by saying just negative 6 and leaving that invisible 1 denominator off. So that's the best answer. Now looking at question 7, I notice that my red line does not touch both axes. So that means I will not have both of these variables. I will not have a y and an x in my answer. If I only touch one axis, like right here, see, I touch this axis, but I don't touch this axis here in the y. This y value, I don't touch this axis here. Right, I'm not touching that axis. So since I only touch the x-axis, then I am going to have only an x in my answer. I touch only the x-axis, and I touch it at positive 5. That is the final equation. See, it's missing a letter because it's not touching both axes. All right, let's turn the worksheet over and try, oh, we got 3 more here at the bottom, I forgot. So this one asks you to solve the following equation. So I have 1 variable here. So these are not coordinate graphs. These are what we call single variable equations. I have 1 single variable right here, and I want to isolate it or get it by itself. So I need to do the opposite of dividing by 4, and I need to do the opposite of adding 3. So I'm going to first start over here with my constant. The inverse of adding 3 is subtracting 3. And then I'm going to go here with my coefficient. The inverse of dividing by 4 is multiplying by 4. And my final answer is w equals 20. Number 9. Here's my variable y. And if I want to isolate y, I need to get rid of this 2 and this negative 6 that I'm timesing by. So my constant is 2. Remember, this negative sign belongs to 6, not to 2. So the opposite of 2 would be subtracting 2. And then when I bring this down, notice I bring down the minus sign with it. And now I'm ready to get rid of my coefficient here, negative 6. And my final answer after I divide is y equals negative 2. Again, same thing on question 10. Remember, this minus sign belongs to 1/4, not 9. So the opposite of 9 is negative 9. And when I bring this down, I bring that negative sign with it. And negative 5 and negative 9 make a negative 14. And then here, instead of dividing by negative 1/4, which is the inverse of multiplying, when you divide by a fraction, you actually multiply by the reciprocal, right? You multiply by the reciprocal. So these are inverses. And now negative 14 multiplied by negative 4 is a positive 56. All right, give your 3 a try on your homework paper, and then turn it over to try the Wednesday box. Again, these 3 equations have a single variable, and the directions ask you to determine whether the equation has 1 solution, no solution, or infinite solutions. And that means that when you solve it, right, does only 1 number work for the variable? Do no numbers work for the variable? Or do every single number work for that variable? So you notice here on number 11 that the left side of my equation and my right side of the equation are the exact same expression. And anytime that happens, you have infinite solutions. Infinite solutions. Any number I plug in here would work. If I plug a 2 in here, I would get 5 times 2 plus 1, and that's 11. And over on the other side, if I plugged a 2 in there, I would get 5 times 2 plus 1 also equals 11. And if I plugged in some different number here, right, let's say I plugged in a negative 3. 5 times negative 3 plus 1, and 5 times negative 3 plus 1. Negative 15 plus 1 is negative 14, and look, every single time I get a true statement in the end, right? And that can be proved here by when you are solving. If you were to subtract 5x from both sides to isolate your variable, you will notice that the variable actually disappears on you. Negative 5x on both sides, and then I get this true statement. That's why the answer is infinite solutions. Whoops. Infinite. It's not working. Let me fix this. Alright, here we go. Infinite solutions. So when you go back and you look at the question, remember, if your left side and your right side are the exact same expression, it's infinite solutions. Now on number 12, my left side has a variable and my right side does not. So I know I'm going to have one solution. The question is, what is that one solution going to be? So for this question, I'm multiplying x by 8, so the inverse would be to divide both sides by 8, and my one solution, the only number that would work, is if x was negative 3. Now in question 13, I have the same exact variable term on both sides, but my constant term is different. So if I were to take some mystery number and times it by 3, and then add 2 to it, it's never going to be equal to that number times 3 if I subtract 5 from it. So these two expressions can never be equal, and here's some proof for you. If I subtract 3x from both sides, I'm going to get a 2 on the left and a negative 5 on the right, and those two numbers are not equal. So that's why this one is no solution. So you can tell just from inspection, that means just using your eyeballs here, when you have the same variable on both sides, but the constants are different, that's no solution. All right, let's take a look at the last box here where they ask you to graph the system of equations. So when you graph a system of equations, you're looking for their point of intersection. So I'm going to start here with this minus 2, right? This is the y-intercept value, and this is my first equation, so I'm going to label it A. And I'm going to graph a point at negative 2 on the y-axis. And then I'm going to use this slope of 3, which means I have a rise of 3 boxes. 1, 2, 3, and a run of positive 1, right? Because this is the fraction, 3 over 1. So 1, 2, 3, and a run of 1. So once I graph that, I'm now going to label it. And instead of writing the whole sentence, I'm just going to call it A, because I labeled it early on. Sentence 2 has a y-intercept of 4. And this time the slope is negative 3 over 1. So down 1, 2, 3 over 1. Oh, there it is, the overlapping point. 1, 2, 3 over 1. 1, 2, 3 over 1. Anytime you have that overlapping point, that is the solution to your system. Right? The point of intersection is the solution to the system. So the point where they intersect is right here, and that is the answer to our question, which is what is the solution? Solution is the point positive 1, comma 1. For question 15, I'm going to label the first sentence A. I'm going to start at positive 5, and I'm going to go down 3 over 1. Down 3 over 1. Down 3 over 1. There's my first sentence, and I'm going to label it with an A. Now I'm going to call my second sentence B. And I kind of notice already that even though they don't have the same y-intercepts, they do have the same slope. And when you have the same slope, that means you're going to have the same tilt to your line. So if I have a y-intercept of negative 4 here, and I have to go down 3 over 1, but I don't have enough graph space, then I'm going to reverse that. Instead of going down, right, I'm going to go up 3, left 1, up 3, left 1, up 3, and left 1. And you'll notice that my two lines are parallel, which means they do not intersect. They are never going to touch, so there's no point in which they have in common. That's a no solution. Question number 16 asks you to name the point shown here. That's the solution here. And its value would be -1, -4. -1 on the x-axis and -4 on the y-axis. Okay, let's take a look at these last few exponent questions. So when you are multiplying like bases, you keep the base the same and you add the powers together. You don't multiply the powers. It says write using positive exponents, so I know my answer is finished. I have a power here, I have an exponent, and it's positive. Number 18, I have an exponent, but it's negative. If I want to make my exponent positive, I need to take the reciprocal. So technically this is a over 1, so the reciprocal is 1 over a. That makes my power positive. Done. And now with number 19, my power is 0, and anything raised to the 0 power is 1. That's it. For number 20 and 21, you're probably going to need a calculator. So if you're using the TI-30X2S like we do in class, then you'll notice that there are some buttons here that can help you with your squares and square roots. So here's the square sign, and here's the cube or fourth or fifth root. That's the any number root sign. And in order to use those little blue keys there, these little blue keys, you have to press the second button first. You have to press that first. So please make sure you're using that button in order to calculate these squares and cube roots and things like that. So if I use my calculator to do the square root of 196, I'd get a 14. The cube root of 729 is a 9. And 13 squared is 13 times 13, which is 169. So good luck with your questions on homework 18.